Almost 7 miles beneath the Pacific, in the deepest water on Earth, a baited trap came back up, carrying an animal no longer than your thumb. They froze it, flew it to a laboratory in southern China, and cut into its muscle. Inside, they found the fallout from hydrogen bombs, not near the animal, not in the water around it, inside its body. To understand how that is possible, you have to go back about 70 years. Through the 1950s and into the 1960s, the United States and the Soviet Union tested hydrogen bombs in the open air. An entire island was vaporized. Cameras miles back fired shutters 10 billionths of a second long just to catch the first instant of the fireball. Every one of those detonations threw something invisible into the sky, a form of carbon that is faintly radioactive. There was already a little of it up there, made naturally. By the time the testing stopped, we had roughly doubled it. Then the treaties were signed, the fallout thinned, and the world moved on. More than 50 years later, that same signature surfaced at the bottom of the ocean in the tissue of a creature that has never once been near daylight. And the bombs were only the beginning of it. Scientists have now cut open animals from 6 trenches across the Pacific, from Japan all the way down to Peru. 7 animals in every 10 were carrying synthetic fiber. In the trenches, tested for industrial chemicals, researchers found a compound we banned before most of us were born, and flame retardants alongside it. In the ones tested for mercury, they found that too. This is the story of how our garbage reached the deepest water on Earth, and how we proved that it was ours. In 2019, a man took a submersible to the floor of the Challenger Deep, almost 7 miles down, and became the deepest solo diver in history. Victor Vescovo looked out through a window at a place almost nobody had ever seen. On the seabed, he reported a plastic bag and what looked like candy wrappers. He did not bring them up. But his expedition did bring up the animals, and that is where the real answer was waiting. The bag was the least of it. Trenches are the lowest places on Earth, long, narrow gashes in the ocean floor, 3 miles below the plains around them. Anything that sinks in the open ocean drifts down for miles. Settle on the ordinary seafloor, and currents can still nudge you along, bury you, stir you back up. The material stays in circulation. A trench is a trap. Sediment slides down the walls and gathers along the bottom. There is no river running through to flush it out, and nothing that lands in the axis is likely to leave it again on any timescale that matters to us. Scientists have a blunt word for a place like this. They call it a sink. Somewhere things end up, so when something man-made finally arrives down there, 2 things are true at once, and the second is worse than the first. It got in, and it has nowhere left to go. To understand what was found, you have to understand the animal it was found in. It is an amphipod, a crustacean, a distant cousin of the shrimp in your freezer and of the sand fleas that scatter when you walk down a beach. The ones pulled from the Mariana Trench measured between 1/2 inch and 1.5 inches long, pale, nearly translucent, with a broad band of yellow-orange eye running across the top of the head. That last detail is newer than you might think. Preserved in alcohol, the color drains out within hours, so for over a century these animals were cataloged and described as blind. They are not, which leaves an open question nobody has answered. In permanent darkness, 7 miles down, what is there for them to look at? You cannot dive down and study them. Nothing we build carries people that deep on a routine basis. So scientists do something much older and much simpler. They build a steel frame, load it with bait, bolt on cameras and traps, and drop it over the side of a ship. No cable, no winch. It freefalls, sometimes for hours. It is called a lander. It sits on the bottom in the dark, sometimes for a day or more, while whatever lives down there comes to feed. Then it drops its ballast and floats back to the surface to be found bobbing in open water. What those landers show is that the bottom of the world is crowded. Bait touches the seafloor, and within hours it is buried under a writhing mass of these animals, hundreds at a time, layers deep. In a place with almost no food, anything edible that arrives is stripped to nothing, and anything that is not edible simply stays. So what does an animal at the bottom of a trench actually eat? For a long time, this was an open question, and the answers people reached for were exotic. Chemicals seeping out of the crust, perhaps, ancient sediment scraped off the slopes and buried for centuries. So far from the sun, it seemed reasonable that life down there ran on some private supply of its own. The truth is simpler and far more unsettling. They eat what falls from where we live. Every bit of sunlight landing on the surface of the ocean feeds something. Plankton bloom and die. Fish eat and are eaten. Waste sinks. Bodies sink. Scientists named that fall marine snow, and it has never once stopped. It is the principal way the bottom of the ocean gets fed. Almost none of it survives the trip. Bacteria break it down, animals intercept it, and of everything the sunlit ocean produces, well under 1% ever reaches the deep sea floor. Whatever does survive settles on the bottom, and in a trench it slides down to the axis and stays. That is very nearly the whole food supply. A trench is the basement of our world, living on scraps that take weeks or months to arrive, which means the sunlit surface and the floor of the deepest trench on Earth are two ends of one pipe, and anything we put into the top of that pipe has somewhere to go. In 2017, a team led by Alan Jameson, then at Newcastle University, published something nobody had checked at that depth. Over several expeditions, they collected amphipods from two trenches at opposite ends of the Western Pacific. The Mariana, just north of the equator, and a second trench, more than 4,000 miles to the south, both deeper than 32,000 feet. They took the fatty tissue and tested it for a family of industrial pollutants, flame retardants, and a group of compounds known as PCBs. It is worth knowing what those were. For most of the 20th century, they were everywhere. Coolant inside electrical transformers, insulation, hydraulic fluid, an additive in paint and sealant. They were cheap, they were stable, and they were almost impossible to break down, which is exactly what made them useful and exactly what makes them a problem. They were also toxic. The United States banned their manufacture in the late 1970s, and much of the world followed. That was roughly half a century ago. Jameson's team found them in both trenches, in every batch of tissue they analyzed, and not in trace amounts. The highest concentration they measured in a Mariana Trench amphipod was about 50 times higher than levels found in crabs farmed in rice paddies, irrigated by one of the most polluted rivers in China. The closest comparisons anyone could find came from coastal water beside dense populations with a long industrial past, like the bays of southern Japan, a chemical we stopped manufacturing 50 years ago in concentrations that would look ordinary downstream of a factory. The chemicals told us something was arriving. They could not tell us when. That is where the bombs come back into it. Faintly radioactive carbon is useful for one specific reason. It behaves exactly like ordinary carbon, so living things absorb it without preference, but it carries a marker you can measure. When the atmospheric tests doubled the amount in the air, they accidentally stamped a date onto the whole planet. Carbon that entered the food chain during or after the testing era carries that elevated signature. Carbon locked away in the deep ocean for centuries does not. Old recycled material reads low. Fresh material from the surface reads high. So in 2019, a team at the Chinese Academy of Sciences took amphipods from 3 Pacific trenches and measured the radioactive carbon in their muscle. If those animals had been living on ancient sediment, the readings would have come back low. They did not. Every sample carried the mark of the bomb tests. The conclusion the team drew was blunt. The surface and the bottom of the ocean are far more tightly linked than anyone had assumed, and the deepest trenches are not isolated from us at all, which settles the question. These animals are not scraping by on old material. They are eating food that was at the surface recently, and it reached them fast enough to still be carrying the signature. Think about that as plumbing. Something enters the ocean at the top. It gets eaten, packaged, and dropped. It sinks for nearly 7 miles. It is consumed by an animal that has never seen daylight. We never sent those bombs to the bottom of the sea. We set them off in the sky, and the ocean carried them down for us. Which brings us to the most ordinary contaminant of all. In 2019, the same research group went looking for plastic, not lying on the seafloor where anyone could see it, inside the animals themselves. They examined amphipods from 6 trenches around the rim of the Pacific. The shallowest samples came from around 23,000 feet down. The deepest came from just under 36,000. They dissected 90 animals and looked inside their guts. 65 of them had man-made particles in their bodies, 72%, roughly 7 in every 10. In the animals that carried anything at all, between 1 and 8 pieces each, most of it was fiber, microscopic threads. Run through analysis, the list came back reading like the inventory of an ordinary house. Nylon, polyethylene, polyvinyl chloride, rayon, which is not quite a plastic and no more natural for it. That is not industrial waste from a spill. That is clothing, packaging, rope, carpet. The residue of normal life shed one fiber at a time, washed down drains and off decks and out of rivers. How it gets down there is not settled. Some of it is dense enough to sink unaided, the rest is too small and too slow to fall that far on its own, so it takes a lift, glued into a clump of sinking debris or riding inside something that ate it near the surface and then died. The researchers list several possible routes and cannot yet separate them, and the deepest trench was the worst. In the Mariana, every single animal they opened had something synthetic inside it. Not one of the 6 came back clean. At this point, you might reasonably push back on all of it. The deep ocean is not a clean room. Volcanic vents leak metals, the crust seeps chemicals. How do we actually know this material came down from us rather than up from the earth? For the plastics and the industrial compounds, the answer is almost insultingly simple. No volcano has ever made a PCB. Nothing in nature spins nylon. Those molecules exist because we made them, and they are down there because we lost them. Mercury is the harder case because mercury is genuinely natural. It also pours out of coal plants, gold mining, and cement works. Once in the water, bacteria convert it into the form that builds up in living tissue and damages nervous systems. It is why you are told to limit certain fish. So in 2020, researchers measured mercury in amphipods and a snailfish from the Mariana and Yap trenches, and in the sediment on the trench floors. They did not just measure how much, they measured the isotopes. Sunlight breaks down some of the mercury near the surface, and that leaves a distinctive imprint on the atoms that survive. Nothing in the deep can produce that imprint because nothing down there gets any light. The mercury inside those trench animals carried the fingerprint of sunlit water. It was made at the top and it traveled down. A second team, working the same problem, argued that much of it arrives inside the bodies of dead fish sinking from shallower water. The exact route is still being worked out, but the direction is no longer in question. So here is what we can now say about the most isolated habitat on Earth. Its animals carry a chemical we banned 50 years ago at levels you would expect beside an industrial river. They carry the signature of weapons detonated in the open air 2 generations ago. 7 in every 10 carry synthetic fiber from ordinary households, and the mercury in their tissue can be traced, atom by atom, back to sunlit water. None of this happened because anybody dumped waste into a trench. Nobody had to. We put things into the top of the ocean, and the ocean did what it has always done. It fed the bottom. It is worth being careful about what this does and does not mean. These studies measured accumulation. They did not show trenches emptying out or animals dying in heaps. The honest finding is narrower and stranger. The deepest, coldest, most remote environment on the planet has already been chemically rewritten by us, quietly, without anybody ever deciding to do it. And it is not finished. The chemicals are still falling. Every one of those measurements is a snapshot of a process that has not stopped and has no obvious way of stopping. The trenches will not clear themselves. That is what a sink is. Whatever is down there now is down there for good, on timescales that make all of human history look brief. We spent a century assuming the deep sea was too vast, too far away, and too dark to matter. It turned out to be the one place that keeps everything. If you want to keep descending into stories like this one, this is Blues Below, where we go looking for what the ocean is hiding. Subscribe and come with us, and we will see you in the deep.